Let's now begin with the consumer's equilibrium principle of equi-marginal utility. Principle of equi-marginal utility occupies an important place in cardinal utility analysis. It is through this principle that consumer's equilibrium is explained. A consumer has a given income which he has to spend on various goods he wants. Now the question is how he would allocate his given money income among various goods, that is to say, what would be his equilibrium position in respect to the purchases of the various goods. Okay, so we're basically going to see how he's going to allocate the given money amongst the various goods that are present in the economy or the market. It may be mentioned here that consumer is assumed to be rational, that is, he carefully calculates utilities and substitutes one good for another so as to maximize his utility or satisfaction. We are assuming that the consumer is a rational consumer and he is going to rationally spend the money income that he has. Suppose that there are only two goods X and Y on which a consumer has to spend a given income. The consumer's behavior will be governed by two factors. First, the marginal utilities of the goods, and secondly, the prices of the two goods. We know that if there has to be some kind of money allocation, then it has to be in two ways. One way could be that you would not two ways, two it would depend on two factors. First is that what is the marginal utility that you're getting from those goods, because that would directly imply what you're going to buy and in how much quantity. The second one has to be, of course, the price, because if something, let's say, is expensive, then law of demand states that you're going to buy less of that good. Okay, the law of equi-marginal utility states that the consumer will distribute his money income between the goods in such a way that the utility derived from the last rupees spent on each good is equal. Now, equi-marginal utility is not explained before or hasn't been taught before either in school or in college, so it's best that you understand this very, very carefully. Let's read this again. The law of equi-marginal utility states that the consumer will distribute his money income between the goods in such a way that the utility derived from the last rupees spent on each good, whatever is the last amount of money or rupee or dollar that you're spending on each good, is equal. Okay, we'll get a better understanding once we read further. So in other words, consumer is an equilibrium position when marginal utility of money expenditure on each good is the same. So a consumer is said to be in equilibrium when marginal utility MU of money expenditure on each good is the same. Each good that you're buying is the same. Now the marginal utility of money expenditure on a good is equal to the marginal utility of the good divided by the price of that good. We already know this, that the marginal utility of the money that you're spending, okay, on a good, let's say X, is going to be equal to the marginal utility of a good divided by the price of that good, right? Where MUM is marginal utility of money expenditure and MU is the and MUX is the marginal utility of X and PX is the price of X. The law of equi-marginal utility can therefore be stated. So we've got three kind of definitions for marginal utility, law of equi-marginal utility. The consumer will spend his money income on different goods in such a way that marginal utility of money expenditure on each good is equal. Stated third time, the consumer will spend his money income on different goods you're going to spend the money income that you have on different goods in such a way that mu of money expenditure on each good is going to be the same. The marginal utility that you derive from each good of money income is going to be equal. Same thing was stated here, in such a way that utility derived from the last rupee spent on each good is equal, or when the mu of money expenditure on each good is the same. Okay, that is, consumer is in equilibrium in respect of this. Okay, so whatever mu you are deriving from buying good X is going to be equal to whatever marginal utility of money. Please remember, marginal utility of money is being equated, and each mu of m is going to be equal to the mu of that good divided by the price of that good, and hence when we are assuming that there are two goods, mu m of both of them is going to be equal to each other. Now, if mu x by px and mu y by py are not equal, and mu x px is greater than MUY of PY, basically the marginal utility of money that you derive from the good X is greater than the one that you derive from good Y, then the consumer will substitute good X for Y because it's giving more marginal utility of money. As a result of this substitution, the marginal utility of good X will fall, right? Mu of good X is going to fall and mu of good Y is going to rise because you're substituting good X for good Y. What? The consumer will continue substituting good X for good Y until mu of X becomes equal to mu of Y, because this is the equilibrium condition. When mu x by px becomes equal to mu y by py, the consumer will be in equilibrium. So basically, if it's greater, you're going to substitute that good for the other good until you come in the equilibrium position where mu m of one good is equal to the mu m of the other good. Let's understand this further. But the equality of mux by px with muy by py can be achieved not only at one level but at different levels of expenditure. The question is, how far does a consumer go in purchasing the good he wants? This is determined by the size of the money income, of course, right? So how far can you go in purchasing a good depends on your money income. You can't spend outside of your money income. Whatever money that you have in your pocket, you can't spend more than that, right? With a given money income and money expenditure, a rupee has a certain utility for him. This utility is the marginal utility of money to him, right? So with the given money income that you have and the expenditure that you have, a rupee has a certain utility for you, right? This utility is a marginal utility of money to the person, right? Since the law of diminishing marginal utility applies to money income also, the greater the size of his money income, the smaller the marginal utility of money to him. Now the consumer will go on purchasing goods until the marginal utility of money expenditure on each good becomes equal to the marginal utility of money, right? Thus the consumer will be in equilibrium when the following equation holds good, where mu of m is a marginal utility of money expenditure, that is the utility of the last rupee spent on each good, which we read in the first definition of equimarginal utility. If there are more than two goods on which the consumer is spending his income, the above equation must hold for all of them. Let us illustrate the law of equimarginal utility with the aid of an arithmetic table given below. Let the prices of good X and Y be rupees 2 and 3. Okay. Reconstructing the above table by dividing MUX of X by 2 and MUY of Y by 3, because we want to get the get MUM. Okay. So we see this. Now what we observe is, suppose a consumer has money income of 24. to spend on the two goods. It is worth noting that in order to maximize its utility, the consumer will not equate marginal utilities of the goods because prices of the two goods are different. He will equate the marginal utility of the last rupee. It is worth noting that in order to maximize his utility, the consumer will not equate marginal utilities of the good because price of the two goods are different. He will equate the marginal utility of the last rupee, which is a marginal utility of money expenditure spent on these two goods. In other words, because this is different, so you can't equate marginal utilities. You have to equate the marginal utility of money expenditure. He will equate this while spending his given money income on the two goods. By looking at table 7.3, it will become clear that MUX by PX is equal to 5 utils and the consumer purchases 6 units of good X. And MUY is equal to 5 utils when he buys 4 units, because we want to equate the both of them. Okay. When he buys 4 units of good Y, therefore the consumer will be in equilibrium when he is buying 6 units of good X and 4 units of good Y, and he will be spending 24, which is the money income that he had, that are equal to the consumer's given income. Thus, the equilibrium position where the consumer maximizes his utility is given by this. Thus, the marginal utility of the last rupee spent on each of the two goods he purchases is the same, that is 5 units. The last rupee that he is spending, marginal utility of that last rupee he is spending is equal to 5 utils. Consumer's equilibrium is graphically portrayed in figure 7.2. Since marginal utility curves of the good slope downwards, curves, we already know how MU curve is sloping downwards. Curves depicting MUX by PX and MUY of PY also slope downwards. Thus, when the consumer is buying OH of X, which is 6 units of quantity X, and OK of Y, then MU of X by PX is equal to MU of Y by PY, which is what we just sought after, right? That of 4 units of good Y and 6 units of good X. Okay, that's the point where both of the marginal utilities of money income spent on that particular good are equal. Okay. Therefore, the consumer is in equilibrium when he is buying 6 units of good X and 4 units of good Y. No other allocation of money expenditure will yield him greater utility than when he is buying 6 units of good X and 4 units of commodity Y. Suppose the consumer buys 1 less of good X and 1 unit more of good Y. This will lead to the decrease in total utility. It will be observed in figure 7.2a that the consumption of 5 units instead of 6 of commodity X means a loss in satisfaction equal to the shaded area ABCH. And B, it will be seen that consumption of 5 units of commodity instead of 4 will mean a gain in utility equal to the shaded area KELF. Okay, so because you were at OH, this decrease is going to be your loss. This is the area which is going to show your loss, whereas this is the from OK you move to OL, and this is the area which is your gain. It will be noticed that with this arrangement, the purchase of two goods, the loss of utility ABCH exceeds the gain in utility KELF. You can evidently see that this area is bigger than this one. Okay. You see, this is still point 0.5. This is 5 units, and this one is till 6, right? So this basically sort of makes it kind of clear that this area will be bigger than this one, because this is on the x-axis, it's equal 1 units. Okay, thus his total satisfaction will fall as a result of the rearrangement of purchases. Therefore, when the consumer is making purchase by spending his given income in such a way that mux by px is equal to mu by py, he will not like to make any further changes in the basket of goods, and will therefore be in equilibrium situation by maximizing his utility. So basically, the last point, all of this area sort of made it clear that if you buy more or less than what is determined by the equilibrium condition, you will the utility that you derive is going to be less. Limitations of the law of equimarginal utility. Like other laws of economics, law of equimarginal utility is also subject to various limitations. This law, like other laws of economics, brings out an important tendency among the people. This is not necessary that all people exactly follow this law in the allocation of their money income, and therefore all may not obtain maximum satisfaction. This is due to the following reasons. Now, the limitations are listed as below. For applying the law of equimarginal utility in real life, consumers must weigh in his mind the marginal utilities of different commodities. Okay, you must weigh in what is the marginal utility of the different commodities. For this, he has to calculate and compare the marginal utilities obtained from the different commodities, right? But it has to be pointed out that the ordinary consumers are not so rational in calculating. Consumers are generally governed by habits and customs. Because of their habits and customs, they spend particular amount of money on different commodities regardless of whether the particular allocation maximizes the satisfaction or not. What is the baseline of this is that whatever marginal utilities it is that you derive from different commodities, you have to keep a check and calculate and compare them. But in actual life, consumers are governed by habits and customs. They spend particular amounts of money on different commodities regardless of whether the particular allocation maximizes their satisfaction or not. For applying this law in actual life and equate the marginal utility of the last rupee spent on the different commodities, the consumers must be able to measure the marginal utilities of different commodities in cardinal terms, right? However, this is easier said than done. It has been pointed it has been said that it is not possible for the consumers to measure utility cardinally. We've already kind of talked about this, the criticism of cardinal utility being a state of psychological feeling, and also there being no objective units with which to measure marginal utility. It is cardinally immeasurable. It is because of the immeasurability of utility in cardinal terms that the consumer's behavior has been explained with the help of ordinal utility by J.R. Hickson, R.G.D. Allen. Ordinal utility analysis involves the use of indifference curves, which we shall explain in the next chapter. So basically, this is the criticism about cardinal utility that we read in the first part of this chapter. Another limitation of the law of equimarginal utility is found in case of indivisibility of certain goods. Goods are often available in large indivisible units. Because the goods are indivisible, it is not impossible. It's not possible to equate the marginal utility of money spent on them. For instance, in allocating money between the purchase of car and food grains, marginal utility of the last rupee spent on them cannot be equated. You can't equate the last money that you're the last rupee that you're spending on the both of them. Like wonderful example here. So an ordinary car costs about 300,000 and is indivisible, whereas food grains are divisible and money spent on them can be easily varied. Therefore, the marginal utility of rupee obtained from cars cannot be equalized with uh, that obtained by food grains. Thus, indivisibility of certain goods is a greater obstacle in the way of equalization of marginal utility of a rupee from different commodities, because equimarginal utility states the very fact that you have to equate the utility that you've derived from the last rupee that you spent on that good. So in case of indivisibility, you can't compare what last rupee that you spent on a particular good, because a car would cost something around 3 lakh rupees, whereas a food grain in the last because it's divisible, so you would probably know the last rupee that you spent on that particular good. So these are the three limitations of equimarginal utility. The concept is explained through examples here, pretty easy, but since it's not done before, it could come out as a challenge. So it's best to read it once more along with the examples to get a better understanding. Along with that, limitations, which are very intuitive because all of this is already discussed in the utility part of the chapter, or the cardinal utility part of the chapter. Indivisibility of goods is something of a money concept, but yes, it's discussed as well in another context, but again, it's very intuitive. So keep a check on all of this. It's an important topic. I'll see you in the next video. Thank you.